Great, great, great. So before we start, we do need a premise for the live coding session. And the premise, I was kind of looking at like what would be an interesting project to make. And lately, my own personal struggle has been with my kids' expenses. In the sense that it's very easy to click somewhere on Amazon or eBay and just purchase something. And then on the other end, it might not be the best purchase. So I thought, okay, hey, let's try to make a tool that will maybe check in another platform if there is a better price, or maybe check the price history and give a recommendation to my kids where they can paste in the link and see if it's expensive or not expensive. Now, we're not going to complete this entire amazing product that I would pay good money for because it will actually save me money if I actually used it. But we are going to at least begin that because I think it has some interesting elements that we can continue and expand. Now, and I'm going to post everything on GitHub. It's actually already on GitHub. So in a sec, I'll see if I can drop the link. Um, this project is a Ktor project, and I just want to kind of briefly talk about the technologies that we'll use. And there's kind of no better way to do it but to talk about the dependencies. Just to talk briefly about the technology stack that we'll use. So, of course, we're going to use Ktor. We are going to use Postgres to save the information. We are going to use Coin, which is a dependency injection that works well with Ktor that I'm using. We're going to use Exposed as the ORM. And this will allow us to quickly kind of save entities in and out of the database. Then we have the OpenTelemetry piece, and we'll talk a little bit more about that before we begin. So this will take care of instrumenting the code and getting information about what the code does. And as we'll see, a lot of that will happen automatically. In terms of the scraping, I found this neat tool, or sorry, library called Scrape-It that seems to work well as well. So we're going to be using that to just scrape some pages and see if we can get the pricing information. If we have time, we might do make some changes and improvements and use RabbitMQ, but no promises. And finally, we're going to use test containers to run the tests. Um, and we're going to use the RabbitMQ and Postgres extension of test containers to be able to kind of do an end-to-end integration test. So this, all in all, is the stack. I do have one kind of caveat is that this is one of my first kind of deeper adventures with Kotlin. I'm kind of new to the Kotlin world, but really excited about it. So I'm going to rely on you, Anton, to kind of point it out when I'm making rookie mistakes, which I'm sure this code is full of. And I'm also going to ask the listeners to be a little bit more forgiving if I do, make these stumbles. Uh, well, I have a background in Java and .NET and Python and a lot of other languages. This is my first foray into Kotlin, but I must say that I'm very excited by it and already saw a lot of great features that the language has.
Nice. Challenge
So
is fun.
yeah, for sure, for sure. So with that, I think we can begin. But before we dive into the code, I just want to say a few words about what we're going to use in terms of observability and OpenTelemetry. So just as a background, OpenTelemetry is an observability standard, and it's not that it's groundbreaking. It's more like an evolution of previous standards. the amazing, important, and extremely meaningful thing about OpenTelemetry is that it is become widely accepted. This is much more important than anything else, because unlike any other time in history of software engineering, we have a standard that is both open. It's a very active project under the CNCF umbrella, and it's widely embraced to the point where, as we'll see in a second, without adding or changing my code at all, I can get a lot of information out of it. And that means that all of these libraries that I just mentioned, or many of these libraries that we've just reviewed in the dependencies, already support OpenTelemetry. And because of that, without changing any code, kind of like with the flip of a switch, I'll be able to get observability data out of my code. And that, I think, is the game changer that OTel brings to the picture. Now, unlike profiling, it's not something you need to turn on and off, especially in dev and test. It is something that you can benefit right away because the data is already there. It's just a matter of how do we listen to it and which tools are we going to use to analyze it. And specifically today, I'm going to be working with a tool that is free for developers, a plugin for the IDE called Digma. I am the author, or one of the authors of this tool. And my goal in this case is not to kind of show you or sell you on the tool. It is more to show you kind of the potential of what we can do with the information if we analyze it correctly. Because one of the lessons of this short code exercise will be to show you that it's not about information, it's about what we do with it and how do we make it practical. Because with OpenTelemetry, we've suddenly kind of shifted from having a problem of not having enough data about the code to having too much data about the code. And what we'll try to do is see how can we actually analyze that data to make things a little bit more practical for us as developers, and not requiring a developer to do a science project or to delve really deep into statistics just to understand if something meaningful has happened or if his code created a regression or not. And I think this is what we need to shift. I would also say that OpenTelemetry integrates with all of the APMs that offer terrific kind of insights over production and other environments. In this case, we're going to talk about dev and test more and not just about production. So with that, I'll just mention that in order to, I kind of created two stacks that you can follow along with. I'm specifically, because I'm used to it and because it saves me some hassle. So I'm going to use the Digma plugin, which is free, doesn't cost anything, and is on the JetBrains marketplace. So you just need to search for Digma and install it in your IDE if you want to follow along. At the same time, if you'd rather use other tools, there is also an open source stack of other tools that I've created that you can use. These are tools like Jaeger and Grafana OSS version and other. And let me see if I can post the link now. And this is something that that you'll be able to use. So just open GitHub. And I think it should be, yeah. So it's under Developer Observability OSS. We can maybe paste, I can maybe paste the link later, but you can just search for Developer Observability OSS GitHub, and you should be able to just run it and kind of have the same results. Okay, so with that, let's start writing some code. So the first task we have for ourselves is to be able to create a scraper. Now, as a sample kind of, I always like to start from the outside in. So I wanted to kind of describe what is the API that I want to create. So for starters, and maybe later we'll automate the scheduling of this or provide additional ideas. I want to create an API. You can kind of see the HTML file here that allows me to send in a specific URL. In this case, we're taking an eBay item that I randomly selected, and for now, just for simplicity's sake, we'll focus on eBay, although we'll have to then add support for other websites. This is something that I almost caught my son buying, so definitely something that I want to provide some feedback about whether or not this is a smart buy. And I would like to be able to send in this request. In this case, it just contains the URL and the name of the website. And I would like the platform to be able to scrape the application that we're writing to be able to scrape the price information from the page. So all in all, a pretty simple endeavor. We want to scrape on the one hand, and then we want to be able to save the information locally and in our Postgres database. Hope that makes sense.
All right.
Perfect.
Looks perfect. I have pasted the link to the chat so the folks could follow along. So
that's great.
We can proceed now.
That is great. So let's start. I created like a structure for this project, so we don't spend a lot of time on boilerplate. But this code is waiting for us to implement this scraping method that is the first thing that we'll do. So I'm going to open up my controller. And basically, the way I've set up this application is pretty standard. You will notice that here you will find a code for instrumenting OpenTelemetry. I've actually commented it out because I am going to use Digma for that. So it's going to happen automatically. But if you are running with the OSS stack, then it makes sense to use it. And it's just some boilerplate code that will enable OpenTelemetry in your Ktor application. If you're using other frameworks, this will also work and will not, depending on the framework, may require a different setup. If you're using Spring, as many of you are, then it just happens automatically if you use the Java agent. Or you can use other methods as well. But again, I'm not going to dive too deep into the tutorial. So we're going to create a new operation. I've been fiddling around with some other ones. And we're going to do a post request. And the post request is going to be about scrape. So all in all, pretty clear. And the first thing we'll need to do is to read the body of the that we've received from the request. And I've created already a DTO that will kind of capture exactly that JSON that we saw before. So this is the scrape request. It's a data class, and it has a URL and a name. So I think that should be pretty straightforward. Nothing complicated about this. Okay. The next thing is let's maybe focus a little bit on the scraping logic that we want to use. So I guess what we'd like to do is to be able to get the website and then find specifically where the pricing element is. So if we, again, open this website, in this case, I'll be wanting to get this particular element inside the HTML. And I can kind of look at, let me open it in Chrome. It will be a little easier. Okay. So I'm just going to copy paste this link. And yep. Okay. So we're going to want to take a look at specifically, this element. And what we can see is two useful identifiers. First of all, we see there is a div class of price primary, and then there is a text span underneath that, and there is a class called price content. So I think we have like enough identification to be able to pull this number. How we'll kind of extract the number from it later is something else, but at least the extraction should be pretty straightforward. So let's see what that code will look like. So just to make it a bit easier, let's kind of create this under our domain package. And let's call this eBay scraping logic. Perfect. And now let's see if we can actually implement the scraping using, again, the scrape it library. So let's write a function. By the way, I love it that in Kotlin you can just write functions without classes when you don't need them.
Oh yeah, that's my favorite feature.
So we'll call it scrape price. We'll take in a URL to scrape, which will be a string. Let's return an integer for the price. And then okay, cool. Oh, no override. That's perfect. And then let's also call this scrape eBay price for now, till we maybe create an abstraction for it. And then we want to use scrape. And the way we use scrape is it can also do the HTTP connection to kind of get the page, as well as it can act as the HTTP fetcher, and it can also help us kind of actually parse the content. So I'm just going to be setting it up here. Yep. It's awesome. And this is very, from what I now understand, idiomatic kind of Kotlin, because you can kind of create these, I guess, coroutines. So I'm just going to define the request to be the specific URL that we that we received as a parameter. Okay, so right now we have the fetching of the HTTP part all done, and then we can define the response. Like ideally, I would separate the two because there are different concerns, but we're just doing something we can get feedback on first. And then the way that they work is that you can actually define like the HTML layout that you're looking for and what you want to capture. So I already did some of that hard work before, so I'm just going to copy paste that in. But let's talk about what I did. So as we saw before on the website, we're looking for a div that has the class price primary, which is what we saw eBay was using on their website. Then we're looking for a span with a class of text span underneath it, and we're going to take the text. So all in all, this is pretty straightforward. And then finally, we're going to need to take that price and return it, but it's still a string, and we'll need to find some ridiculous way in order to parse it, because I'm not going to create an engine now that checks like any kind of permutation of string that can be used to show the price. So let's just create something that will allow me to quickly get the information out of the price without maybe doing it very accurately, just for this the sake of this example. So I've written a ridiculously simple price extractor that has this property that it just takes the string and it filters only digits. So we're going to get a number. I don't know what that number means, but at least it's going to be an int, and we can start using it later. We can make this a little better. So I'm just going to run this code on the price.
Well, chances are it will be a correct price, but there might be decimal points. So if you keep a dot in that string, maybe it will give you a double, and it will be much more likely to be a price. But well, it's just a thought.
Yeah. Well, we'll save that for the next iteration. But for now, we have like the parsing, the scraping logic, and we can actually connect to that through our controller. So let's go back to the scraping controller that we created. And so now theoretically, we could do something like scrape eBay price, and then pass onto it the scrape request URL. Okay, and we can check that this works.
Do you prefer running the apps in debug mode always, or currently you're running in debug mode because of OpenTelemetry?
Oh no, we don't need to do
Setup.
that at all. Let's well, actually, we can kind of show that it works without even debugging it. So let's do that. So what we're going to do now is because we know that OpenTelemetry actually, you know what, let's do the following. We want to make sure that we can maybe save the price and not have to debug in order to see that value. And that's a great opportunity to talk about another OpenTelemetry concept. So first of all, let me run this code again. And what you may have noticed as this code was running, and this was just because I had Digma enabled, is that it used an agent, the OpenTelemetry agent, in order to, you can see it here in the output, in order to activate the instrumentation over this code. And the next thing I'm going to do is actually run the API that we've defined, just to see that I can trigger this code. So let's go to the request HTTP file and run this. Okay, so we have our post request. Okay, we got not found, and that's fine because we didn't actually return anything. So let's fix that. So let's, for now, just return the, it's a call response, right? Or
yeah, respond, I think.
Respond, yeah. And then we want to use HTTP status code. Okay. Okay. Yeah, I think this should be better. Let's rerun. Perfect. And let's run this again. Okay, and now we got an okay result. But beyond the fact that we got the okay result, I think it's a good opportunity now that we've run this code for the first time, that we can look at what we actually managed to record out of all of this interaction. Because we were working with OpenTelemetry, let's see what type of information OpenTelemetry can bring us. So we can see this call to the scrape method. And if I click on trace, oh, sorry, I had to change something in the setting. Let me fix that for a second. I was just goofing around before. Okay, so if I open up this trace, I can actually see a lot of information. So we can actually make it, let me make this a little bit bigger for everyone. So we can actually see exactly what happened. And again, this is without changing any code. So we can see the post scrape request that actually occurred before. So we can see, exactly which route and which port and so on. And then we see the GET request that we made to the eBay website, and we can see kind of the website that we called. And finally, and we'll take a look in a sec why that happened, we see our ridiculously simple extractor being called. And these things we got automatically. But at the same time, right now, we created some logic that we might want to also kind of follow along to understand exactly what is happening, what it is being triggered. And the way we can do that with OTel is also extremely simple. All we need to do is to add an annotation over this code. And we can actually do that automatically. So you can see here that we have no observability. So we just click add annotation. And now it's waiting for data for the next time that we run this code. It will also tell us more information about this specific piece of code. Does that make sense?
Makes sense. Let me recap so that we are on the same page. Whenever application is running with the agent and some activity is going on in the app, so we hit it with a request, either a get or post, whatever, the agent starts collecting the information or recording it and sending it into a trace server, right? Wherever it's holding the data, right? And
so
then
everything here is running locally. We're not sending to any remote server or anything like that. And the way this works is that um, Ktor, for example, or the HTTP library that I'm using, um, already has support for OTel. So when it sees OTel is on, it uses an exporter, which basically sends the observability data using that format to any destination that I want. And you can actually configure it to send to multiple destinations. So you can see people sending logs to logs.io and sending or to Coralogix or sending tracing to Grafana or Datadog. It doesn't matter. You can kind of have the freedom to select which tools you want to use, which is another great advantage of having an open source spec, because you can have a lot of value add tools on riding on top of it.
Right. So there is a storage, and the agent
Mm-hmm.
sends the data to a storage. Doesn't have to be the server
Mm-hmm.
outside of your computer, but it can be a
Mm-hmm.
server on your computer, right? Then you
Mm-hmm.
connect with Digma plugin from the IDE to that server to download the information and data to visualize right in
Mm-hmm.
your ID, right?
Yes,
What
exactly.
question I came up with when I was looking at this trace is how is it filtered? Like, how do you decide which methods are relevant and which are not? Like, is there a package filtering, or is there
Mm-hmm.
some heuristics that
Mm-hmm.
says, okay, now we are in this application, that is why we want to monitor those invocations, and the others are not interesting for us, and so on?
Yes. So the answer is yes. And let's take a look at how we do that. So first of all, what I did just now, I added the whiz span annotation over here to this scrape eBay price method. And let's see how that kind of changes things for us. So just going to rerun it.
So this annotation is used by the agent for instrumentation, not just for
Yes.
filtering. Hmm.
Yes, it's used for instrumentation. And what we're going to do now is just trigger that same post call that we triggered before. So yeah, we can even run it a few times so that we have a little bit more data. Perfect. And now we can see, oh, you see, immediately we have some new information. And we're seeing some interesting things appear. So first of all, we can start seeing that the kind of performance profile of this specific location ranges from 1 second to almost 2 seconds, which is quite a lot, to be frank. Um, the second thing we can see is who's using this particular code. So we can see that this is used by the post scrape endpoint, which is correct. And of course, if we had additional breakpoints, then, or sorry, additional endpoints using this, then this would be a great way to visualize that and understand. The third thing we see is that we've created a bottleneck, essentially. So this code is running synchronously, it's blocking, and it's creating for us a very long API code that we may have not noticed before. Because just running it in my IDE or triggering a post request did not reveal the fact that I was actually creating a pretty slow request, and it is something that I want to always kind of get a handle on. And the last thing is I want to know, why is it taking so long, right? And all of these are very simple questions, right? And they're all in the data. All we're doing right now is trying to analyze what they mean and bring it to my field of vision as a developer. So the last aspect that we're seeing here is where does the time go? And again, this is not based on just one call. So far, counting, we made 4, but we could have hundreds of calls. And the more information we have, the more kind of we're capable of analyzing it to reach more and more conclusions about the code scalability, about the code performance, about different issues found in the queries, and so on. And so what we're seeing now is that our ridiculously simple price extractor is really ridiculously small also in terms of its performance footprint. However, the HTTP GET to eBay.com is predictably taking most of our time here. So what we're seeing here is really the bottom line after looking at our trace. Does that make sense?
Totally.
Perfect. So having said that, we can also look at kind of all of the different things that Digma picked up on. So there are 3 endpoints. There is this endpoint right here, as well as other endpoints that I played with previously. We have some database queries that I captured before. We have HTTP clients like the ebay.com GET. And we have like other locations that we've also kind of found because we're running RabbitMQ in the background, and we'll get to that maybe later. And as you mentioned, we can also focus on a specific microservice. Right now, we're looking at this Ktor example app, but if we had others, we can focus on them as well.
Mm-hmm.
Does that make sense?
Yeah.
But let's try to kind of maybe expand, and just because I see we're well, this is such a fun session that we're running out of time, that I'm just going to kind of paste in some additional code blocks to make it a little faster. And of course, everything in this example will be available, and like everything that that I did in this project. So just to make this a little faster, the main thing we need to accomplish now is actually to save the website and pricing information. So just reviewing it really quick, we're going back to our scrape controller, and we want to basically get or create the website itself because, oh, sorry, I didn't quite talk about it, but I created some objects to represent all of these this data in the database. So the way it works is, let me pull this up. So we have, I created 2 repositories to save the website and the website price. And the way that this is defined is we have, and this uses the DAO interface of Exposed, is we have this website table that has a name and a URL, and it actually references price records. And then we have a price record table that has a timestamp of when I scraped the price record. So we can have multiple price records per item. So let's say this yesterday I scraped this item and it had a different price than today. And the price record has the price, the timestamp, and then a reference in the other direction towards the website. So these are just the simple entities that I've created. And I created a repository just for simple operations around them, like saving them. And then going back to my scrape controller, what I'm going to do is get or create the website based on the request that I received. So basically, we're going to look if there is a website already existing. If not, we're going to create it. And finally, we're going to, once we have the price, we can save the price record and just essentially create a new price record. And yeah, and we of course need to change this so that it is now, we created this as an integer. Okay, so this is it. Basically, we have the entire end-to-end and of having just saved a price. And we can check if this works. So let's run it again. And as we rerun it, we can also create a new item. And we see that we, again, got a good HTTP response. And if we now take a look at what the recorded information is, then we can see that, yes, we can see that bottleneck that we've identified around the scraping. And we can also see the additional information like the select statement here. Let me make this again a little bigger. So we can see in the trace the select statement. We can actually see what the select statement was. And we can kind of see all of that information available to us. And if we want to go to, let's say, this particular location, this is also kind of a one-to-one mapping. So we can go from here back to the code where this is happening and so forth. So we have fully navigable traces that can take us to the trace and back into the code. Okay,
Perfect.
That's interesting. Now let's take a look at, again, because we have like 15 minutes remaining, I'm going to steamroll through the rest of it. So I've also created an API to get the list of prices. And just as a reference, I created the latest API. So this is going to be just the latest prices that I've gathered. And you can see here a nice list of APIs that I've scraped together, including the latest calls from eBay. So we can take a look at that, as well as I've made a few determinations in order to display whether something is expensive or not. So let's take a look at that just to give my kids that guidance that I wanted. So going back into the HTTP, we can see like some of the requests that I created. So we saw about how to get the latest, but we can also get the prices for a specific URL. Let's say the URL that we used before. And basically, this will give us back whether or not it's expensive, which it is. And we can kind of play around with different permutations of this. Awesome. We can notice some interesting things pop up. So, for example, as we kind of look at the queries that we're making, let's take a look at the latest, for example. So this is the call to get the latest. And here we can see some of the queries are actually taking a lot of time for us, which is interesting. And if we take a look even further, we can go to that specific query that we see is used by multiple APIs. And we can try to understand what the problem in this case is. Like, why is this query taking so long? And this is the kind of things that you can notice right away when you look at the at how the trace is structured. That something is definitely wrong here in this particular trace. And these are the things that normally you would really miss if you just ran a test. So like one of the things that observability can provide us is it can actually help us find issues that are invisible to tests that only check the functionality. And in this case, we're seeing a lot of weird things. First of all, okay, the formatter is repeating a lot. But at the same time, and this is a very long trace, we can see that it's actually doing a lot of different selects and conversions, whereas maybe it's something that we can save. At the same time, if we look at the implementation, we can see that it might be fetching like the latest 100 records, but it also might not be the best way to do that. And also, it seems to be not using a suspended function and coroutine, which we would benefit from in this case. So just looking at the code so far, we can already see some issues are starting to pop up. In another place, in another API where I was trying to create some C data, we can see that we immediately picked up on the fact that there were way too many queries. But in that case, that is fine because this was just seeding the data. But again, this is something that we can take into account, that can actually sometimes reflect on the fact that there is a problem that we missed. But let's see how we can try to fix some of these problems and verify that that the code now works as expected. So before we were looking at the example where when we scraped, we saw that the scrape operation took way too long. And as a result of that, let me bring that up. As a result of that, we had this bottleneck around the scrape operation itself. And what we can try to do is eventually I want to move this to RabbitMQ and have this be a consumer instead of a synchronous operation. But for now, what we can do is try to make this entire operation asynchronous. So let's try to do that. So first of all, let's see where this is triggered. And we can see that it is triggered just normally like any function, and we're not taking advantage maybe of other things that we can do. So let's first of all make this a suspend. And then let's do something like, I think you can do like a global scope launch, which is like the most horrific way. Don't do it at home, but it will get the job done in terms of launching this asynchronously. And of course, we want to actually do it maybe like this. So this entire thing happens asynchronously, and then we save, and that's independent of the fact we're just returning OK. So that should work too. And now what we want to do is to say we want to recalculate this or recheck this bottleneck. It will eventually get cleared, but we want to test it right away. And we want to rerun it again. Is it this? Oh, sorry.
Oh, the build is running right now?
Oh, it is. Sorry, I didn't notice. Okay, cool. So yeah, let's run it again.
Yeah, let's clarify. Global scope is a delicate API. Don't use that as it's currently being used. And I think the compiler actually warns you about that and will require you to.
Yeah, kids, don't do this at home for sure. But what we're trying to do is show how if we actually make this asynchronous, we can maybe resolve some of the issue that we have with our API being slow. So let's check if that worked. So we can look at creating the item. Yep. Okay. And we can see the times are much better, right? It's like before it was over a second. Now we're kind of down to mere milliseconds, which makes sense if you think about it. And similarly, let's go back to our scraping logic. Okay, and in a second, this will refresh. Let's give it a sec. Oh, I think did I run my app a little differently now? Let's try this again. Oh yeah, sorry. Yeah, I was running it a bit differently. Okay, so if we look at this again, we can see two things. First of all, that the request breakdown now recognizes that this is an async function. So instead of seeing this pie chart, we actually see that we have DB queries that take up really negligible amount. The internal spans are really close to 0 or less than 1 nanosecond. And then we can see the HTTP clients are actually taking more than the request itself, which makes sense, which is over a second. So right now, this entire thing is being as asynchronous. And as a result, we actually don't have this issue we saw before with the bottleneck. So this is just an example of an issue that we can catch very quickly while we're developing. In addition to that, we have like a lot of other issues we can catch from N+1 queries. I actually fixed one in this code before, like issues related to scalability and issues that tests can actually accurately point out.
Nice. Well, it's actually pretty simple. If you visualize how your application is working, you can fix a lot of things without actually diving deep and doing crazy optimizations and so on.
Oh, for sure. And let's take a look at testing then, which is another kind of interesting aspect of it. So to check, I created like an end-to-end test using test containers. So we have here our Postgres database, and we're setting it up, and then we're just overriding the environment variables to use the Rabbit and test and Postgres that we've created for this test. And we're going to be running the same logic via a test. And let's see what happens when this happens. So test containers are actually pretty fast, but like they have like a little bit of an initialization time. Okay, so this is done, and we now also ran our test. You can imagine running your entire test suite to get similar results. Now, once we've run our test, we can see that here on the local test, we have kind of exactly what happened. And one of the nice things that we can take a look at is we can look now at that specific span that we saw before. Let's say this select query. And we can look at the tests that actually trigger that select query. So I'm going to pause for a second. What we did right now is we went from having a trace, which shows you exactly what happened. Let me make that a little bigger. So we had this query. You can look at the trace. this is like the updated trace after we've added a couple of things. And we can see the select statement that we're using here. And what we're also seeing is errors that it's been exhibiting over time, which is interesting, but also the tests that actually trigger it. And if I go ahead and optimize it, and then I want to run the relevant tests, then I can just click run. And this will run all of, or this test, or if I have multiple, I'll be able to run all of the tests that actually touch this piece of code, in this case, this query, not even a piece of code that the code is running. And this is a great way to, first of all, again, recheck if you're having any issues, and make sure that your code is um, running correctly, especially if you're fixing these types of issues that you're seeing live as you're coding. Now,
Very nice. Very nice.
the vision of what we're trying to do here, and I think this is like we're at the top of the hour, right? This is it. We have like a minute.
Yeah, we are not like strictly limited
Okay,
with the time slot, but let's see what's in
yeah.
there.
So the vision of what we're trying to do here is really just this: to be able to, as kind of a developer, have that capability of seeing these issues much earlier. So you can imagine that eventually all of these things will catch up with me. If I have bad queries, if I missed out on indexing, if I used synchronous code that's blocking something important, they will show up eventually. But you can imagine what the ramifications are if the longer you wait in finding them out. And there are a lot of these graphs that show you the increasing cost of finding issues later in the cycle, which is exponentially higher. So finding an issue in testing, now that requires some additional work. Finding an issue in CI after you've, or as your pull request is already being there and you need to now go back and change your work, that takes more. And if you find it in production or in later stages of testing, then that has exponentially greater effect. So what we want to do is shift as many of these checks over to the developer as they're working, instead of waiting until these issues are picked up by monitoring, which is a very reactive thing to do. Like when you monitor something, then it already happened. And that is the goal of what we're trying to get to with Digma, with OpenTelemetry, and with other tools. We're trying to make sure that developers have that visibility. Because I'm going to put it in another way. If I did not have that visibility, how could I have known, right? How could I have known, or how could I expect my developers to know if they don't have that type of information? So I like to give an example of this. I had a developer who wrote this amazing piece of code, and we only found out a few months later that it was never actually called because he made a bad if statement. And when I asked him, what's going on? How do you not know that your code wasn't called? And he said, well, how am I supposed to know that? Like all of the tests passed. I didn't put a breakpoint there, but how was I supposed to know that my code wasn't called in production or in CI or even in testing? And
Code
yeah, and this
coverage?
code coverage is nice, but in terms of testing, right? But nobody has 100% code coverage.
That's true.
And if you do, then you might be also optimizing the wrong thing, because it's not the most important thing to have great code coverage. There are other things that you want to have. So I think that what we're trying to do is make it possible for them to see that their code is called. And the same way that this works, by the way, for the local environment could also work for CI and staging and production. So right now I'm looking at my local environment and my local test environment, but I can also add a CI environment, for example. And in that case, this would just integrate with, or this would the same OpenTelemetry data, only this time sent by CI or sent by production. And this is where we can actually provide developers with the ability to see not just what's happening with their own code, but what is happening with other code as well, or with the code that they have as it's running in different production systems. And this is where it makes sense in both ways, both in validating my code and even as a design tool. So think about the task of approaching having to change a piece of code and being able to visualize who's using it, what type of experience it's currently providing, and knowing to design it better.
True. Totally true.
So I kind of scratched the surface, I think, only about kind of the things that we can detect on the code. But I think what I hope to accomplish was to uh, provide kind of clarity about two things. First of all, that OpenTelemetry is almost trivial to enable. Like with Digma, yes, I can even do it without changing anything. But even if you don't use Digma and you use the open source stack, it's just a few lines of code to get that information. And now the question is, are you going to benefit from the information that's already available about your code or not? And then the other thing that I wanted to make more kind of emphasize is that this has blind spots for us as developers. Like all of these things, the fact that we don't know them precludes us from making really important decisions and fixing really important bugs before they emerge.
I see. Well, that was a nice demo. And we had Kotlin, we had Ktor, we had IntelliJ all in the mix. And I really like how it visualizes the data. And I spotted a few things. Maybe I can ask you
Mhm.
right now.
Yeah. Mhm.
Whenever it highlights that there is a bottleneck,
Mhm.
uh, how does it decide to
Yeah.
highlight that? Is it the percentage? Like, it's definitely not a threshold in milliseconds. What
Yeah.
heuristics does it use for highlighting the bottlenecks?
Yeah. So it looks at requests over time in order to decide whether or not this takes up or it checks how many threads are waiting on this operation to complete and what is the percentage of time out of the total request that this is taking up. So if it is above certain thresholds and it's holding up other processes rather than being run asynchronously, then it will be considered to be kind of a bottleneck for this request. And there are thresholds also in terms of time. So uh, if it's
Hmm.
1 millisecond, it's probably not a big bottleneck. But if it's an HTTP request and it's taking more than X amount of time, then it is a bottleneck for that request.
I see. And I also noticed, like you actually showed it, that you log the SQL statement,
Hmm.
um, like the text of the SQL
Hmm.
statement. And in that specific example, it was a prepared statement. Do you also log the parameters, or is it possible to see the parameters?
Yeah, so that's a matter of preference. It is possible, but I think by default it's masked, just because you may be working with production or sensitive data. So by default, the parameters are masked. I think in this case, it's also using a syntax where that would be a bit more like it's. I think it's using SQL parameters in a way that would make it more difficult to get the actual values. Um, I'm not sure. I think it is possible to change it via a config setting so it doesn't mask the parameters.
I see.
Uh, One other thing that I could do, by the way, um, just to show you, if I'm interested in a specific value, So let's look at this scrape eBay price method. So what I could do is go to span current and then set attribute. And this would allow me to say, let's say I want to create an attribute called a price, and I want to log the price that I just received. So this is also something that now if I reran my code, I'll be able to see in the trace itself that value. Again, if I want to debug or troubleshoot exactly what happened, then this makes it very easy to do that.
Mm-hmm.
You
Mm-hmm.
can see.
While it's running, I'll read a question from the chat. Alex is asking, what's the purpose of OpenTelemetry, and is it like micrometer? So I guess you can give a better answer than me. So for me, those are two monitoring technologies. One is de facto standard today, and the other one de facto standard yesterday.
So yeah, let me maybe explain. And I think, by the way, we can look at the price here that we just recorded. So micrometer has its own library that also supports OpenTelemetry. So if you're using micrometer tracing, then it supports OpenTelemetry completely. In fact, if you're using Digma, and this is, I think micrometer tracing only works for Spring for now, but if you are using Digma with Spring, then you have the ability to select between OTel agent and micrometer. Both are working with OpenTelemetry. In terms of micrometer tracing, I think it's right now it's kind of a trade-off. Micrometer tracing is much more performant in terms of running it in production because it uses less magic and less reflection and things like that in order to enable observability. On the other end, it requires no, if you're using the agent, you're looking at no code changes to get started, and it will include much more information because it just enables like data all over the place. So if you're looking for quickly getting experience with OpenTelemetry and getting a lot of data about your code in dev and test, I would start with agent. If you're looking to get, if you're working with Spring and looking to instrument in the production environment, then I would definitely use micrometer tracing.
I see. Nice, thank you. So we are over time, but it's still it's fun to learn something, and we still have folks on the stream. And well, thanks everybody for coming. Thank you, Ronnie, for the awesome demo, and stay tuned for more announcements on this channel. And have a nice Kotlin.
Bye.